some of this stuff is just really quick review from last year. There's different ways to write ratios. Do y'all remember that a ratio is really just it's really the same thing as a fraction, but there's a lot of different ways you can write it. If you look at the written exercises on page 289, for instance, 14 to 21, they tell you to write it in simplest form. I could have written this as 14 over 21 as a fraction, but we can also write it this way. How would I simplify that? Yeah, it would reduce, wouldn't it? You could divide both things by 7. So 14 divided by 7 would be 2, and 21 divided by 7 would be 3. So this is all they're wanting you to do there. If you get confused, like on number 3, where you see 24x to 8x, if it helps, go ahead and write it as a fraction. That's one way that might help you see to reduce it when the x's cancel out. And then 8 goes into 8 one time, 8 goes into 24 3 times. If I were writing it as a fraction, I would just put 3, wouldn't I? But if I'm writing it as a ratio, I'd actually have to put 3 to 1 there. So just know that, you kind of, when you write it this other way, you have to have something on both sides of the colon, even though when we write it as a fraction, we might leave it off. So again, they want you to simplify some ratios. And like number 9, it says 20 minutes to 2 hours. It's hard to compare that because they're not in the same units, right? So let's get it in the same units. You could pick whatever you wanted to. I kind of always go with a smaller unit. If I've got 20 minutes, how many minutes are in 2 hours? 120, right? 2 times 60 would be 120. Okay, so get the same unit so that you can actually reduce this. Doesn't 20 go into 21 times and 20 go into 126 times? That's what we're doing there, is getting the same unit so that we can actually reduce it. We can't reduce them if they're not in the same. Remember that what a proportion is in 7.2 is what we're getting at, is we're going to take two ratios and we set them equal to each other and we solve. How did we solve proportions? What do you do? Well, what's a quick way to solve them? Remember, you cross multiply. Do y'all remember that? Okay. The thing about ratios is you can use them for so many things. That's why we're wanting to kind of remember them. Let's start with an easy one, and then we'll go work on the harder ones at the end. Let me start with number 3, okay? Reducing fractions, 7-2 is actually solving proportions, two ratios set equal to each other. If you look at number 3, you get 8 over 5 equal 4 over 3x. And, we wouldn't have to use a proportion here. If we wanted to solve this, we could multiply both sides by 5 to get rid of one fraction, and then multiply both sides by 3x to get rid of the other fraction. But if you remember, the quick way to take care of that is to cross multiply. We can say 4 times 5 is 20. So if I multiply one diagonal, I can set it equal to, so you've got to remember your equal sign. I know that's something a lot of people tend to forget. You set it equal to the other diagonal multiplied. So 8 times 3x would be 24x. Well, I have to solve for x. They do want me to solve for x, so these are just little solving things, okay? So to get the x by itself, I would then divide by 24, good. So if you think about it, you're going to get x equal 20 over 24, but they're going to want that reduced. That's what 7.1 was all about, was reducing fractions or ratios. So what would it be? 5 over 6. Yeah, 4 goes into 20 5 times. Yep. 4 goes into 6 times, so it's going to be 5 over 6. That's what you're doing on these problems. The ones that are earlier on look a little easier, so we'll kind of go to the end now and work, because that's probably where you're going to have more questions. Bless you. Okay, so you're going to solve them the same way. They've got variables on both terms, but again, that's not that big of a deal, because remember, it's a fraction equal a fraction, so that's called a proportion. And we can solve it by cross multiplying. Doesn't matter which diagonal you start with. I'll start with this one. It's 4 times 5n plus 3. I'm going to go ahead and write that down, even though some people would multiply that out in their heads. If you can multiply it out in your head and write it down, that's fine. I'm just going to kind of try to do smaller steps, because not everybody can do the multiplying in their head and not mess up. 5n times 3. I could write that down as 5n minus 3 times 6. I could write that down in that order, but wouldn't my brain handle it better if I wrote the 6 in front of the 5n minus 3? It's like when I write the smaller thing in front of the larger thing, you know, the 6 in front of the 5n minus 3, my brain kind of knows to distribute there, doesn't it? So I could write 5n minus 3 in parentheses times 6, but just, you know, kind of think about those things when you're writing it down. Is there a way that you could write it down in order that might make it a little easier for your brain to kind of decipher? Usually people like this order better. So now we just have to distribute. So let's start with the left side. 4 times 5n makes 20n. And 4 times 3 makes 12, right? And then on the other side, 6 times 5n makes, good, 30n. And 6 times negative 3 is negative 18. This is so much easier than what y'all just did in that last chapter, isn't it? It's kind of, you know, hopefully this will be a nice little brain break. Now, do you remember that when you got variables on both sides of an equation, it's usually, most people prefer to move all of them to the side that has the most. That way you avoid creating negatives. So I've got 20n on the left and 30n on the right. If I don't want to have to mess with a lot of negatives, it'll be better if I move the 20n over on the other side. And if you remember, this 20n, I can move terms from side to side by adding and subtracting them. I just can't split them apart by adding or subtracting. I can scoot that 20n to the other side. I can say, lazy math guy didn't put a plus out front, but he could have. I could write 20n plus 12 as 12 plus 20n, couldn't I? Aren't they the same thing? So I can kind of remember that and think, well, what's the opposite of a plus 20n? Well, I could just subtract 20n from both sides. We were doing this morning in 7th grade, pre-algebra. Okay. So if I do that, all I'm going to have on this left-hand side would be 0 plus 12, but lazy math guy knows that 0 plus 12 is 12, so he just writes it down, doesn't want to waste his ink or pencil or whatever he's writing with. And on the right-hand side, what's 30n minus 20n? 10n, okay? And then we got a minus 18 to bring down. Okay, so trying to get the variable by itself. And for those of you who had me last year, you know I like to circle it because that kind of helps you focus. It tells you focus on that side of the equation. Don't go try to move that 12 from side to side. That's going to kind of be, work in vain there. How do I know what to move first? What can I think in my head to help me know? I'm going to start writing it and see if any of you remember. Yeah, PEMDAS backwards. If you don't know what order to go in when you're solving things, if you think PEMDAS backwards and write it on your paper, that can keep you on track. I'm supposed to add or subtract anything to get it away from that variable that I can. And I see that there's a minus 18, so that's an add or subtract thing. And I always say, what's the opposite of subtracting 18? Adding 18, right? Okay. So we're going to add 18 to both sides because that makes it go away. Really, that's what I want to happen. I want it to disappear, and I want to get my n by itself. And that makes it add up to 0, doesn't it? That's why it disappears, because 10n plus 0 is just 10n. So that's why we did that. And I had to do it to both sides. 12 plus 18 is 30, right? N is still not by itself, but it almost is. It's multiplied by 10. What's the opposite of multiplying by 10? Divided by 10. So if I want to get the 10 to go away, I got to do its opposite thing. It's multiplied when it's smushed together. Opposites dividing. 30 divided by 10 is 3. I get n equal 3. And I'm done with that one. But yeah, for one, good, very good. For one like 23, where you've got a fraction on one side and a whole number on the other, remember, this in solving with proportions so easy because you can just cross multiply. I mean, I wouldn't have to use a proportion. I could multiply both sides by 7 and be on my merry way. But if I wanted to, I could write, since I've got one side as a fraction, I could write the other side as a fraction just by sticking that over 1. And that's another easy way to take care of things. And we use this a lot in a lot of, almost every year you use this idea 2 or 3 times in a different way. I can cross multiply now. I can say 2 times 7 is 14. And then I can say, okay, that was one diagonal. Now I'm going to multiply the other diagonal and set those two things equal. 1 times 6 plus 4n, oh, that's just 1 times anything is just itself, isn't it? Okay, so once I do that, then I just got to think, okay, let's get the variable by itself. So you multiply each diagonal, put the equal sign in between them because you're setting them equal to each other. We use this idea in geometry a lot. It's a nice change, isn't it? That was some nasty factoring we just got done with. Okay. So if I'm going to get this by itself, PEMDAS backwards tells me to add or subtract anything from the variable that I can. And even though I might not realize that there is a 6 added to that 4n, Lazy Math Guy just doesn't write the sign of things that are up front, does he? I could put that's a +6, and to move it to the other side, I could say the opposite of a +6 is a -6, or I could just subtract 6 from both sides. That cancels out, makes a 0. 0 plus 4n just leaves me with 4n over on the right-hand side. And 14 minus 6 is, what, 8? Okay. Or 4, right? Yeah, it's 4 times n, so we're going to divide both sides by 4, and we'll be done, and the n is 2. I think you knew the answer, so it was coming out. So n is 2.